Hello, everyone. Welcome to our third FHIR Foundational Series session hosted by Digital Square. This session will focus on FHIR terminology, both project-specific as well as global. For those of you who are new to Digital Square, we work with innovators, governments, and donors to support country digital health programs. One of the ways that we do that is we support adaptable, interoperable tools that are designed to work together seamlessly. And we support interoperability in this community through webinars like this. So welcome. Before we get started, just a few notes. The session is recorded and will be posted on our wiki a little later this week. So we ask you to please mute yourself so we can hear the speaker clearly. We'll call on you if we need to have you speak at any point. I am pasting a link to a Google Doc in the chat. Please put questions there. Leave comments, any suggestions for other webinars, or find registrations for the next webinar or recorded webinars, the previous webinars in this series. We will have about 10 minutes halfway through for questions, and then again 20 minutes at the end for questions. So again, please throw as many questions as you can in that Google Doc. We will get through as much as we can. And then before we move on, I am going to ask that everyone come off camera for a minute and let us take a photo. We don't get to see the folks that we get interact with very often, so we'd love to see your faces. Perfect. Anyone else? Okay, I will take it. All right, so I will just go ahead and introduce our speakers. So today we have with us Robert Hausman, who is a consultant in clinical informatics and also a physician in family medicine with substantial medical practice experience. His current work focuses on clinical terminology, data modeling, and healthcare data standards development. He is a long-term active member and participant in HL7 and currently serves as a co-chair of vocabulary and orders of observations workgroups. He is a FHIR core specification editor and an active contributor to the development of HL7 FHIR standards for the information exchange, including FHIR terminology services and several FHIR implementation guides. He is the US co-lead for the HL7 International Patient Summary Project and the primary developer and editor of the IPS FHIR implementation guide. He also actively participates in the development of SNOMED CT and LOINC standard clinical terminologies and is the HL7 co-lead for the SNOMED on FHIR project, which provides guidance on using the SNOMED CT terminology within the FHIR information standards. So he understands our terminologies quite well. This session will be co-hosted by Jose, who has led our previous FHIR sessions. Jose is a data management standards and interoperability consultant who has worked in the sector for over 20 years. He developed Orbis and IPAC's healthcare products. In addition, he has been involved in integration projects such as the development and integration of data analytic systems in Europe and Latin America, integrations in large hospital groups in Paris, and contributed to the National Integration Framework in Belgium. He is the co-chair of the IHE Pharmacy, as well as an avid supporter and contributor to FHIR. He's been contributing since 2009 to global healthcare standards, HL7, IHE, and ISO, and also facilitated the launch of HL7 and IHE work groups in Brazil, Portugal, and Belgium. So I will turn it over to you, Joe.
Hi. So the session today is going to be hosted mostly by Rob, as you were introduced. So he has the credit that he authored the materials that we are going to see today as part of his continuous engagement in the FHIR working groups. And with that, the plan for today is, let me just share my screen. The plan for today is that we will go through the first through the basics of terminologies. So sorry for multitasking. I guess you can see my screen now. So today the goal is to, first part is to understand how FHIR works with terminology. So a bit of what terminologies are about and how FHIR works with them. So when does something become a terminology aspect or not? So how code systems and value sets, or the core FHIR concepts for this, how they are defined, identified and used throughout the specification, and how we can use this to specify these kind of resources to use binding in FHIR models and resources and profiles, which is where we left off. So last time we spoke, we were talking about profiling. Terminologies are a part of the profiling effort. So when we do something, we normally have the need to express some needs in terms of terminology. Second part is going to be a bit more practical, that we will understand how the terminology services are working, how FHIR technology, we understand that how FHIR technology works with that, and we will show or we'll explain some of the services that are most common and go through them and walk through them. So this is the plan for today. First part, introduction, and second is a bit more hands-on. And with that, I would actually leave the word and the floor to Rob. Rob, thank you for helping and for hosting this, and go ahead.
All right, thanks, Jose and Verinda, for the introduction. I'm really pleased to be able to be here with you today. Let me go ahead and share my screen. Get that done here. Let's see. All right, you should see the slide now. So, okay, as Jose said, we're going to start part one, introduction and fundamentals. I was going to say, I'm really glad to be able to be here with you today. I wasn't quite sure if that was going to be able to happen. This happens to be my week, being possibly summoned for jury duty, but it's not happening until tomorrow. So I'm able to be with you here today. So that was a good thing. So we have quite a bit of material to cover, and I'll try to go through this first part particularly fairly quickly. There's lots of nuts and bolts, so to speak, just kind of, again, as it says, it's introduction and fundamentals. And some of you may know this already, and some of you may not. I don't know everybody's background, of course, but we will go through this, and then again, we'll have few minutes for questions after this, as Jose said, and then we'll have more time for questions at the end. So the main topics that we're going to try to cover are where we can find information about terminology in the FHIR specifications. It's obviously important to know where to look, for things, and so we'll show a little bit about that, and some basics on, what tools do we have available for representing coded data in FHIR. We'll go through the details there. Look at the primary FHIR terminology resources, and then some of the other important, but maybe not quite as bread and butter terminology resources. So where we find terminology in FHIR, the first place to go is what shows here. This diagram, you basically have, there's a terminology module. It's level 2 on the home page, as you see here, and it's the primary organizing place in the FHIR specification, for looking at terminology details. And this link should take us there, and I'm going to try to do as much interaction as I can during this. And so actually, I'll go back to the home page, but you'll see right here is where I was pointing in the FHIR specification. So if you, if you don't know where to go, it's a good place to start. And then that gets us into that picture that I showed there, the diagram. And in the terminology module, we basically can, we go through and have that sort of one-stop shop to find all these details. And this diagram, we'll see more of this as we go along, but it has some good links and references to kind of help you keep it all in perspective. And then it has more details lower down here, where we can get into all the specifics on the resources and the terminology service and the various operations available, and the coded data types, and some links to documentation. So it's an important place to be able to find things and to know about that. So, and the other place that I want to highlight is the Terminologies link, and that's always on this red banner at the top of the screen over on the the far end, link to Terminologies, and that is probably the quickest and easiest way to get to terminology content, the actual content in the FHIR specification. That's the specific details of the code systems, value sets, and concept maps, and so forth. So if we look up here, we go back, we have that link there. And if I click on it, then, it takes us right to the code systems. And then you've also got tabs for value sets, concept maps, and identifier systems, and as well as some documentation on how do you use codes and resources. Very helpful information. So, if you look at, there's lots of code systems listed here, and some of these may change in the future, particularly external ones. Some of these are moving around to other places, but right now, this is what we see in the specification. We've got information on SNOMED and ARCS, NORM and LOINC, and various other terminologies right there handy. So another place that's very important to know about, to go to, is the FHIR Zulip chat, the terminology stream. That's where you can get answers to your questions, and chances are that you may get answers at any time of the day or night, depending on where you're located, because there's somebody up and doing something around this usually available. So it's a great place to go and ask your questions. And just I think it'll take too long to log in. I should have done that ahead of time, but let's see if just want to give you a flavor for what's out here, if I may. There was a recent discussion about the terminology server and multiple codes for concepts and a number of other things. And so this is an active place for discussion. And the actual link over here, I'm losing. Oh, it takes a little bit time to refresh. We won't, since we have a lot of material to cover, we'll let that go. But anyway, that's make sure that you use the Zulip chat whenever you're looking for further information, or want to need to ask somebody something specific. It's a great place to go. So now we'll talk some about again the details of how do you represent coded data in FHIR. And so we want to start out with a code. And what a code is, it's a symbol that's used to represent a specific meaning or idea. In other words, often called a concept. And so code represents a concept, and a couple of examples are the SNOMED CT code 195967001 is an identifier for the concept of asthma, and that asthma is a type of disorder concept in SNOMED CT. And different terminology in the FHIR definition use code system, FHIR-structure is the code, and it represents a particular FHIR structure. Ideally, according to the Semino Desiderata vocabulary principles, if you're familiar with what those are, we talk a lot about meaningless identifiers, and but as being the general best practice. But FHIR actually chose to go a little bit different direction, to choose sort of at least semi meaningful type of codes, which are more implementer friendly. The whole idea of the FHIR specification is to try to aid the implementer as much as possible to be able to to use this material. And we found that having some information in the codes can be actually very, very useful. And so we've kind of deviated a bit from some of the what you may hear out there, but it has its downsides too. But that's what we do in the FHIR defined terminologies typically, and just be aware of that. So now, one thing we don't have in FHIR right now is a separate resource for a code. That doesn't exist right now. Codes would live inside code systems, which we'll talk about more, and value sets and all that, but we don't have a FHIR resource for code. It is being discussed that there might be a possibility in the future, particularly if we start getting more heavily into the terminology authoring space. But right now, that's not something that we have. It's basically terminology servers, which we'll talk about more, are there to help kind of take care of those details for us. And so this slide talks about some of the big primary standard terminologies, SNOMED CT, LOINC, and ICD, particularly ICD-10 is probably the most common these days, but ICD-9 in the past and ICD-11 coming up in some point in our near or distant future, depending on where we live, I guess. But why do we want these global standard codes? And these particular ones, SNOMED is a comprehensive set of structured coded concepts. It has codes for lots of things, findings, symptoms, diagnoses, procedures, and all the rest. And it's developed internationally with with national bodies providing input to that. And there are licenses that are required. There is a freely available subset of SNOMED CT called the Global Patient Set, the GPS, which is available, but for full use of SNOMED require a license, and basically it's membership on a country basis. So your country typically would be a member of that. LOINC is also a global code system. It's primarily, at least initially, it's for laboratory test procedures and results. It basically it has licensing conditions, but there's no payment required for it. But it's a very widely used coding system, particularly for a laboratory. It also has a clinical LOINC side, which has other kinds of details and sometimes overlaps in some respects with SNOMED, but they're really for different purposes, and they're often very complementary to each other. And then the ICD-10, basically has the list of codes for diseases, for analytic purposes, epidemiology, classification, and basically purposes. And it's from the WHO, and then there are also local flavors of it. Like in the United States, it's ICD-10-CM, and in Australia, it's ICD-10 AM, I think it is, or AU, I can't remember which. But anyway, there's local variants of that in many countries. And I think we need to change the link on the slide there, but because that's back to LOINC, but we can give you a link to ICD-10. So now let's talk a little more detail about what FHIR has for allowing us to do this. And we'll start with, beyond the code, we go to the code system. A code system is basically it's not, of course, unique to FHIR. The idea of it, logically, it defines a set of concepts which have codes, of course, as we said, but a set of concepts that have a coherent meaning. They relate to each other in some way or another. They have often sometimes explicit relationships, or they have at least implicit relationships with each other, and they should all form some coherent set. So example would be SNOMED CT, and it has in FHIR we use the code and display and definition, and they have correspondences with what's in SNOMED CT. And here's a list of some of the other code systems you might be aware of. Again, we talked about already SNOMED, LOINC, and ICD. It's also the ARCS norm, and actually NDFRT. I should update this. It's now been changed to MED-RT. But ICPC, some people use that. ICF-CPT procedures in the US, and there's a lot of others. We won't go through all of those, but it can also be other kinds of things that we wouldn't maybe always think of. HL7v2 tables can be code systems. HL7 version 3 also has many code systems, and things that you might have more locally, like drug formularies, or config tables, or enums in a Java class, or the ISO country codes. There can also be code systems. And basically start building out this diagram that we were showing earlier, and we have the code system that defines the set of concepts with a coherent meaning, and then a value set looks at code systems basically and selects a set of codes that are for use in a particular context. And so an example here might be the SNOMED CT codes for fractures, fractures of bone. And some other examples, it could be European country codes or particular LOINC codes that I need to use in my application, or various others. But maybe a particular sub-hierarchy of SNOMED CT, like findings or procedures or pharmaceutical products, various kinds of things like that. Those are, you can create value sets of these that are, again, these selections of particular sets of codes that you have a particular context of use in mind. And so this slide's about CodeSystem versus ValueSet, and why do we really need both of these? Because often they can be kind of mixed and mixed up and misunderstood, especially for value sets that are defined, which sometimes they are, as all codes from a code system. Basically, they look like they're the same thing. But value sets, again, can be a little different, and they can actually contain codes from more than one code system. Usually we try to avoid that, but sometimes it's very appropriate, particularly if we have, a set of clinical codes and then a set of, codes for absence or unknown or things like that that you might need to include and have in the same data element. Sometimes the value set may need to include those codes, and they may be obtained from a different code system. That's one example where that can apply. There are others, but the idea of this is that we want to separate the definition of a concept, which is done in the code system, and the use of the concept, which is done in the value set. So this is a relevant thing for folks making FHIR profiles, knowing what's defined, either by you or by someone else. And you want to keep this straight to avoid getting into trouble when you're trying to exchange your data. So the take-home points, again, are code systems define symbols that have specific meanings, and the value sets define the collections of codes for use in a particular context. All right. So now I'll build out the diagram a little farther, and we'll talk, say something about terminology binding. You have, again, the code system. You have the value set that selects, a set of codes from that code system. But then you also have in FHIR the element definition, which is basically defines a data element, and it has a notion of binding, with its particular characteristics and a reference to a value set. So an example in FHIR would be condition.code. So it's basically the thing that tells you what condition is this? Is this asthma, or is it pneumonia, or what might it be? And to select a value to put in that code element in the condition resource, you basically would have a binding in your profile to a value set. In this case, it wouldn't be the SNOMED CT fracture codes, of course, but it could be if it was, you're looking for conditions about fractures. But when I was talking about pneumonia or asthma, it'd be some other binding. But anyway, you have a binding that's useful for your particular purpose. And so you choose a value set, or sometimes there can be a choice of value sets even, but that meet your clinical needs. All right. So you need to know about binding strength, and there are 4 of these in FHIR. Start with the lowest one, which is example. Basically, there's some codes here that we've selected and put in a value set that gives you an idea of what you might want to use, but there's no expectations around that, no recommendations, nothing like that. Just something to get you started, basically, that you're thinking about what you want to do. But if the designers of the profile or whatever have a little bit better idea of what they think is good to use, they might choose a preferred binding. And the idea there is that you really should use these if you can, but if there's some good reason where you can't, maybe your country doesn't allow it, maybe your country requires you to do something else or whatever, then you can choose something else in your own profile, and you can still be conformant with the FHIR specification. Going a little bit beyond that, the extensible binding basically says you must use these specific codes if they apply. The word apply here is a little bit loosely defined. How do you know when it really applies or doesn't? And there could be some discussion around that. We won't get into that right now, just be aware of that. But if it does apply to your case, you must use those codes. But if if they're something you need to represent that's not included in that bound value set, and so therefore there's no code that does apply, then you are still free to use other codes or just text if the value set doesn't cover the concept you're looking for. But then if we go to the highest degree of strength, we have the required binding, and there, in that case, you must use the specified codes. And if you can't find one, if there isn't one, you have to omit the element. And that's true, unless it's a required element, and then you basically have to choose a code. So that's usually used mainly for structural items in the FHIR specification and all of that. But that's how the binding strengths work. And so you put all that together and you have the full diagram. And so you've already seen all this. I won't go through the details again, except for to mention, when you look at the element instance, this is the actual, in a resource instance in FHIR, and you've got that, say, that condition.code that we were talking about, where you're going to put this code in. Basically, that element, that coded data type has to conform to the element definition. So basically, it has to follow the value set binding that was, defined in the element and all that. But the code that's selected does not refer back to the value set. That's an important thing to realize. It actually refers directly to the code system, because the code system is where the meaning comes from. That's always the anchor. And so that's why you don't see any references to the value sets in your coded data types. So this just says about how you refer to a code system, and you have the system and version and the code itself, which is obviously the most critical thing, but the system is also critical. You have to know what code system it comes from, otherwise the code really doesn't have any meaning. Display is an optional item, but it may be very extremely useful for human readable representation. All right, so let's see how we're doing on our time. And I think okay. We'll talk more a little bit about the data types now, the coded ones, and we start with the simplest one, which is just the code data type, and it is just a code. That's all it is. It's basically a single value. In this case, the code system is fixed. It's already defined, as in the modeling. It's not represented actually in the data type itself. It's it's in that element definition. Can't be anything else. You have to look at the element definition to know what code system it is that we're talking about. And the value set is also fixed. It's typically almost always a required binding, and it doesn't have a separate display name because that's already known. And this is again used for these structural elements, like I was mentioning. And they're really essential to basically enabling the fundamental interoperability, and it's for things that are reasonable to standardize at the international level. Basically, to say anybody anywhere in the world that uses FHIR and uses this resource, has to use has to use this code system, and so this particular value set from the code system. You have to use these set of codes, and nobody can choose something else. And these are required bindings that we're talking about typically. And so bundle.type is one of those. There's a few others, but not quite a few. All right, so that's the code data type. And in this case, if you're using that, well, what if you need a different code? Well, the code data elements, they're not extensible. You can't send your own custom codes. Basically, you only have one slot to put something in. But if the coded element's optional, then you can just omit it and you can send an extension instead. Or if it's a required element with a min occurs equals 1, it can't be left out. Then you basically have to choose that code that's closest, the one matching your need. But if you have something additional, you could use an extension to send additional codes or whatever that you want. But if you actually run into this, then maybe the specification is actually not adequate, and you want to consider submitting a change request to fix it and make it better in future versions of FHIR. All right. So now we'll move on to the next level, where we have the coding data type. And basically, the main points of that is you're able to specify both the code and the system. Those are the primary elements. This data type is actually not very often used directly. There are a few examples where it is, like this one I've listed here, consent.purpose. I think we could just take if you're in the consent resource and we find purpose, there it is. and you see that it's a coding data type. So it's again, that's not the most common situation, but there are some cases where it's appropriate. But if you typically, if you need one coding, you may well need more. And the only time that you wouldn't be if you don't really care about having any ability to have additional codes, what we call translation codes. So if you're sending ICD, do you want to also have a SNOMED code? Or if you're sending ARC's norm for medications, do you want to also have ATC? Or, if you need to be able to have multiple coded representations, then you need to move on beyond coding and go to the CodeableConcept, which is next. And there's a question which maybe we can answer in the QA time if we have, but why is everything in the coding optional? You notice that system, version, code, display, and user selected all are optional. So basically, theoretically, you could have an empty coding data type, no elements. That wouldn't be very useful, but might be interesting to think through why you think that might be the case. Maybe we can answer it later. So now we move on to the most common coded data type, which is the CodeableConcept. It's the most generally applicable and useful. And basically what it is really simple. It just has multiple coding elements, 0 to star here, and plus a text. So you have potentially multiple ones of the multiple codings. All are considered equal. There's not one that's the first one or the highest priority one or any of that. There's no notion of that. But one of the conditions, one of the codings in there, if needed, can be set as user selected if there's a reason to do that. Like if it actually came from the user interface or something, you can do that in the coding, but you don't do it here in the CodeableConcept. But if you need to identify a particular coding as being what the user saw, then it is possible to do that. But to maximize interoperability, the basic rule is to send all the codings that you know. If you know multiple code systems for this element, you send them. That'd be the best. And text is supposed to be the representation of the entire concept. It should be entered, not entary, but we can fix that. And this can be used as a fallback for systems that don't recognize your code. It's more human readable. It's always good practice if you have it to send it. All right. Again, I'm moving through this stuff pretty quickly. Hopefully we'll have some time to ask questions about the details, but codes versus identifiers, that's an important distinction. The slide kind of shows that, but basically the code has, with the coding, it's got the code itself and the system, as we talked about, and the display optionally, and it represents the meaning or concept. Identifiers, these are kinds basically, but it sometimes also covers real things like countries and states, even though those are, there's a little bit of a gray area whether that's the United States. There's only one of the United States. It's not a kind. There's only one of them. There's only one of Germany. There's so maybe you could actually consider that to be something you would use an identifier for rather than a code. But some things are commonly represented that way and have a gray area. But most things either are kinds, like I'm a person, this is a car. There's many instances of all those things, but the code says what kind of thing it is. The identifier identifies, particularly a single item, like I was saying, but instead of a code, it has a value. They both have systems. There's code systems and identifier systems, and then you got labels and all that. So you need to be aware of that distinction. It's not, and we do have some tools for dealing with identifier systems, in the FHIR space. All right, let's look a little more detail at the resources. We've talked about some already a bit. The CodeSystem resources, is the place to start, and it might not be exactly entirely what everybody might first think about it in the FHIR context. Its real main purpose is to declare the existence of a code system and its important properties. So this is where find out what your identifying URL is, to reference that code system in your coded data type instance, and also potentially its version. it has other details like, of course, the description, copyright, publication date, and other kinds of metadata. And, maybe a little bit about how you can use it. Are the codes case sensitive or not? Are they version safe? The meaning, does the meaning of the code actually change from one release to the next? Some code systems have done that in the past. We're trying to ensure that code systems don't do it in the future, but some may still do it. Some code systems can be a little more sophisticated, like particularly something like Snowman CT has a compositional grammar and can define expressions, and this can tell you whether that's the case or not. And it can define filters and and various properties that you can use elsewhere in the FHIR ecosystem. And so that's what CodeSystem is primarily for, but it may also include some of the content, the actual concepts, particularly for large code systems. The bottom bullet here, like SNOMED and WIKE and all that, we do not expect to see the contents of those showing up in a code system resource. Those are handled in terminology servers and all that. The code system resource for these would basically describe, again, their existence and their properties, just like it said. And but particularly for smaller code systems, in some cases you may find that the full contents or part of the contents may be included in the resource. But the code system resource is not intended to support maintenance process for code system. That's handled elsewhere in terminology space. All right, so this is, we won't look at details of this, but this is the UML diagram that shows kind of how this resource is structured. You can kind of peruse that more at your leisure. It's in the FHIR specification. And I'll just move on, and we will talk, show, this is showing an example of the definition of a code system resource. You start by declaring that it's code system, then you have the various elements that, including the URL, important one, various other identifiers for the code system if they exist. You can look at the version, of course it has a name and what status and all these items. And then you get down here to concept, and if this is defining the content and says this is a complete one, then it would have one of these concept elements for each each concept and code in the code system. So that's a very simple example. That's the definition. And anyway, that's the basic, that was the code system. And now we can move on to ValueSet. Again, we saw how that, the diagram kind of was built on each other. And the ValueSet again ValueSets use the code system resources by referring to them, through those canonical URLs, that I mentioned. And we use them in element definition and questionnaire resources to specify those allowed contents for the coded elements. That's the binding that we talked about earlier. And in case you know about the ValueSet definition, the VSD spec, we attempt to align with that as closely as possible, sometimes with extensions, but we'll talk in detail about that right now. So let's look at the diagram of that as well. Again, I'm not going to try to show you all the details of these, but if you like looking at the diagrams, you can figure out more about how these things all fit together. All right. But some of the things about the parts of a value set, you have a lot of metadata. You got its URL. Again, it's used to identify it in the bindings, particularly, and other things about it, where you can find out more about where it comes from and how you might use it. Probably the most important part is the definition of it, which is in the compose element. Go back. That's the logical definition of what content is in the value set. It has the codes to include or exclude. That can be done by an entire code system. You can include a whole code system if that's appropriate, or you can list codes individually, or you can use filters to select certain codes out of a code system to include in your value set. And you can also include other value sets, or you can also exclude all these things as well. Anything you can include, you can also exclude, and you can build up the set of concepts that you actually want for your particular purpose. And then we have this notion of expansion. These two things go together. The compose defines it, and the expansion then says, well, looking at that definition, and let's process that definition and look at what, with the code system as it is today, maybe it's more than one code system, all the code systems with their particular versions, what is going to be this actual set of codes that we have. So if SNOMED, we're using SNOMED and it updates to a new version, then that value set definition may stay the same, but the actual expansion of the value set might change. It might get some new codes because depending on how it was defined, if SNOMED has added some new codes that would fit into that definition. So that's kind of how that works together. All right. So value sets are versioned, and that's important to know about and to understand and use them when they're needed. If you don't have a version for your value set, there's some potentially unknown content. And that's really what I was just talking about. If you define a value set based on some characteristic of a code system and that code system has an update, then your contents of your value set will change. So that's the unknown part. Sometimes you want that to be unknown because you want to keep moving on with medical knowledge and all that. You don't want to be locked into things, but there are times where you really need to be locked in and you need to know exactly what's there. And when that's the case, then you need to, set your versions. Okay, so this is an example that shows how Compose works. And this is you have the value set resource here, a little bit of metadata. We got the Compose element, which we're going to include a set of codes. In this case is for the FHIR code system condition verification status, and we use a filter basically to say I want to have all of the concepts that are some either unconfirmed or some subtype of it. So because this code system has a little bit of hierarchy in it, and so we can use the ISA operator to do that. And so we define our value set that way, and then if we expand it, then we would get we get a value set resource back, another one, but it's basically it has the expansion element, which then has the content that is in that expansion. And so we would see that code that was mentioned in the definition unconfirmed. We also see two other codes, provisional and differential, because those are below in the hierarchy, they're below unconfirmed. So they're types of unconfirmed. And so all three of those concepts would be returned in the expansion. All right. So we'll talk about a few more terminology resources now. And again, I know I'm flying through this material and I'm watching the time as I do. I think we're probably still doing okay. So we say a little bit about the concept map resource. Basically, it represents a list of mappings between concepts from two different value sets. It's typically based on value sets. Normally, those are going to be from different code systems or models. There are some cases where you actually might map between concepts within the same code system. It's not prohibited, but typically you should define two different value sets that you're mapping from and to. And this provides the data, or it can provide the data that's used in the translate operation. There's a translate operation on concept map that allows you to move from the one code system to the other, basically. And so this is just a simple example of looking at codes for addresses. Basically, you might have a home and a work address and a temporary address and all that. And then you have another code system, which basically this code home is equivalent to the code H there, and work to WP and temp to TMP. But then old doesn't really have any mapping, essentially. So there's different ways to specify all those things. That's between the FHIR and difference between the FHIR and the HL7. The FHIR address code system. Basically, I don't have the actual name here, and the HL7 v3 address use code system. But anyway, that's what that's for. And we'll talk a little bit more about that when we hit the translate operation. And NamingSystem is another resource, and it's basically there to identify existence of either a code or an identifier system. This is getting to be used quite a bit in the terminology.ho7.org that's being developed. We call it THO, where you can have basically an HL7 kind of a one-stop place to get terminology. And we're not going to really talk about that, but you can go find that. But there's a lot of use of NamingSystem there, and it tracks, how different ways that these code systems or identifier systems have been referred to over time. Whether you can manage your identifiers that way, and that's one use of this. They're typically defined by third parties, somebody other than the code system or identifier system owner. So like SNOMED, defines its own things, but in HL7 we might have a naming system resource that would show different ways that could be identified. All right, terminology capabilities is another one of these less common but potentially very useful resources. It basically says for a FHIR terminology server, it can tell you what additional capabilities it has in the terminology space. The basic capability statement will tell you what operations it'll support and things like that. But the terminology capabilities resource can tell you more about what code systems and value sets are supported, and and you can get to it by using the metadata endpoint with the mode equals terminology, like it says here. So it's useful to be aware of that. All right, and I think that actually gets us to our first bit of questions, and I know I flew through that, and actually I think I'm ahead of schedule according to so that's maybe not a bad thing, because we probably need to spend maybe a little extra time on the next part of it if we can, so maybe that's good. All right, so let's see. So I think we were going to do this part. So you can ask questions of me, and Jose and I can try to answer the questions. And what do we have?
You have something in the Google Doc?
Yeah. Oh, okay. Maybe someone. I can
ask them. I can ask them.
Yeah, that'd be great. Appreciate it. Yeah.
So first question is: we can promote these global regional resources for use by the different interoperability labs in Asia. Which FHIR resources can be freely shared at the global regional level? This is from Alvin.
Okay. I'm trying to make sure. You want to say that again, Jose? I think I got it, but
we can. So the question is: we can promote these global regional resources for use by the different interoperability labs in Asia. I presume that the global regional resources. I presume that Alvin would be talking about the SNOMED and ICD codes, not the FHIR things themselves.
Yeah, that's what I'm thinking too. I was trying to make sure I understood that. Yeah. Well, yeah, let me say, I guess, a couple of things, and I don't know if it's completely on track or not, and we can do a follow-up if we need to. But one thing I guess we have to be a little careful about is our terminology, particularly since we're talking about terminology right now. But when I hear the word resource in a FHIR context, I'm always thinking of the actual FHIR resources. What we were just going through, the code system, value set, concept map, those kinds of things. But I think that's not what we're talking about in this question. Probably, I think Jose is probably right. He's probably thinking of the code systems, and there's a lot of.
Sorry, and Alvin confirmed that this is indeed the correct interpretation of this question.
Yeah. Okay. Yes, I see that. Okay. Great. Well, so there's a lot of aspects to that answer, but and it varies a lot potentially between code systems. But the basic, I guess, idea is that all the code systems, would have a license of some kind, pretty much. Just about everything does. There may be a few exceptions, but some licenses are just to basically say that you need to, attribute, where this is from, and you may not be allowed to alter it or things like that, but you're able to freely use it. So some code systems like Loink have a license of that. It says basically, you can use this, you just can't change it. But you don't have to pay us, you don't have to, do anything specific, other than just acknowledge it. You have to put the license in, where you are using it and make that visible. And, there's various kinds of, requirements, but a number of code systems are licensed that way. SNOMED and some others are not quite as freely available. And actually, the WHO code systems are not really as freely available as if you, and some of the other, national code systems, you actually have to purchase to get copies, things like that. But once you have it, then you can send the codes. SNOMED CT, again, has contributions from members all over the world, but they actually have basically a country by country license. So if you're in a licensed SNOMED member country, you're free to use all of SNOMED, including its concepts, descriptions, relationships, all of that. But if you happen to be working or living in a country that's outside of that, it doesn't have a national membership, then you can use only a more limited set of what they provide, the global patient set that I mentioned, and or you can get your own license, or your company can, or whatever. But there are ways to do it, but yeah, you have to look into the details for each one.
Another question is, and sorry if I skipped the next one, is will there be value in agreeing on value? So these questions are still from Alvin. Will there be value on agreeing on value sets like the VSAC, the VSEC at the global level? Rob?
Well, there is. I guess the answer, I would have to say yes. There's some value. It may be something that's actually. It's not done everywhere. Most people work in their own spheres. People do work within their own countries and all that. But there are definitely. I think we can all appreciate, what we've been through these last 18 months or so. Why it may be important to be able to exchange data, across our national boundaries and things like that. We certainly can see that, with what we're looking at with the COVID-19 vaccinations and all of that. Wouldn't it be great to be able to, and we're working on the ways to be able to exchange that kind of data. And, the project I'm working on, the International Patient Summary, is also very much interested in this question. How can we exchange data and have it be meaningfully used, from one country to the next, across, potentially multiple boundaries, and figuring out what terminologies can help us do that it's quite a challenge. But it is valuable, and it's hard, I will say that, but I think it is ultimately progress can be made that can make it useful. That's my take on it.
Just another question. I think it's tightly related to that, and I would also add some comment after the answer. The question is, can the global FHIR IPS community prescribe a starter kit on which interoperability labs can build on? The starter kit may have code systems and value sets shareable in the global /region. So is that something that Rob, I think I guess the answer, but the main question is, can the global FHIR community and IPS community prescribe or recommend a starter kit of terminology resources, value sets, and
yeah,
code?
Okay. Yes, the answer is yes to that. We are, we've done that to some extent. And again, I'm speaking, kind of putting on my IPS hat here mostly, but also my broader FHIR hat as well. FHIR has, throughout the specification has, various levels of bindings. Many of them are example bindings. Again, this is stuff that you might want to use, but if it's something that is considered, maybe generally usable, then we might, you might see a preferred binding or something like that in the base FHIR specification that would suggest this is something that might have, potentially broad applicability. But the ability to do that in the FHIR core specification is fairly limited. Again, we don't really have, you can't say there's multiple choices here or anything like that. When you get more into the implementation guide space and profiling, then you can do more of that. So like in the IPS IG, right, we have places where we have multiple slices. I don't know if everyone's familiar with that term, but in FHIR profiles, you can basically have multiple choices, multiple options that you can look at. And so one of the things we've done is we've created slices that have different value set bindings. For medications, as an example, we have a slice for, you could use SNOMED CT for that. I mean, most people, I don't know anyone locally other than that uses the SNOMED, at least not at the international edition level, for their own medication use. They use something more detailed, but it may have links to SNOMED, and they may be able to use those codes. But ATC from the WHO is also another one that can be used. And so we have we basically provide a choice of those, and we're trying to provide recommendations and choices of what can be used. And I'm also working really actively right now on an update to the IPS, which will give more explicit choices and actually reduce the optionality a bit and make it more likely that we can move everyone towards something that's going to be more interoperable. And so we're actively trying to develop that right now. So we are trying to do exactly what you're asking for, but it's all a work in progress.
Yeah, and maybe I can just add quickly the work that Path and Digital Square that we are doing throughout the different communities and the different topics. So it's not easy to say this is the value set that will be used for everything, but it is easy to say for antenatal care or for HIV care or for some of these things. Here is the start, as you call it, the starter kit. So here's a couple of things, or here's a couple of profiles that we'll have, or a couple of guidance, or a couple of value sets, a couple of terminology resources that should provide a basic or let's say a sufficient starting point. And if you really need to exchange it, then you can. If you really need to change this, then you can change it. But the advantage there is not to try to have one value set that is sufficient for all purposes, but purpose by purpose or topic by topic, we can introduce those things. So that's the role, as Rob mentioned, of implementation guides, as we saw in profiling the last session. You can always catch up on the video and ask around. But when we do this on an international level, so the work that we have ongoing for HIV, or the work that's ongoing for antenatal or perinatal care. So those things, they are sufficiently specific that we can say this is an international value set that you can use. And things that are designed to be international, they are more likely very good at being localized. So that could meet the need for a starter kit. I think it's a valuable point, and I think that is what several groups are doing. IHE, Digital Square, Path, we are doing that. I hope that helps, Alvin. Okay, and
other questions? Or?
Just one question, but I think that one is good to keep responding in the chat. Alvin asks, who among the participants have set up their own FHIR servers and what resources they reuse? So we have a couple of initiatives ongoing from Path, but I would ask the participants to please jump into the chat and mention if they are using if they have set up their FHIR servers and which resources they are using. Those are the questions we have at this moment.
Looks like there might be a new one here. Let's see. Okay, question from the dev perspective. There's a
there's a FHIR.
FHIR, yeah.
It's one reference implementation of. Sorry, Rob, you want to take that one?
No, you go ahead. Yeah,
so it's a reference implementation of the FHIR specification. So there's a couple of them. One of them is Happy, so it's the Java-based. There's several implementations, many of them open source, so you can start with anything you want. And the FHIR is official, so it is a product that is out there for the community. Everyone can contribute if they want. Everyone can use. And that is fully compatible with the core FHIR specification. If you have in your country or in your project, if you have specific constraints, then FHIR might need to be tailored for those constraints. There's a whole lot of discussions on that. And again, the best way to get there is through the community. Start with chat.phir.org, and you can ask these questions, more detailed questions there. Yeah. But yes, it is something that is official. Well, HL7 is not responsible for that. HL7 says this is the specification, and there's a couple of reference implementations out there, and everyone can make a reference implementation, but the ones that are there, they are most mature and most compliant.
All right, well, let's go ahead and go back into the rest of our presentation. So I think we can, again, we'll have more time for some additional questions on this material. Again, we went through it pretty fast, I know that, but we can ask more questions about that and about the next part, when we get to the end of that. So, all right, let's see. Okay, so part 2 is about searching and services. And so the main goals are, basically that we want to talk a little bit about how to understand and use the FHIR terminology-based search capabilities and the terminology service capabilities. Those are, related but slightly different things. And then we'll also cover a little bit, a few things about some scenarios and strategies for how to use the terminology services and where to use them. And there's also some slides which we won't, really talk through, but you'll have available to, some references for servers and tools and some additional topics. So we'll go into terminology-based search and the terminology service and and all of that. So we already talked about that. Okay. All right. So we'll start with the search, like I said, and I'm going to, this is the more, as I think Jose said, but it's more of the hands-on part of this, and so I'll be going back and forth between the slides and the browser. Typically, usually the browser should be all that we need to, but we'll be hitting one or more FHIR servers and showing actually what is the input and the output for those, and kind of go through and try to give examples of everything that we're doing here. So basically the simplest search that deals with terminology is the token search, and it basically works on the principle of an exact match, but it has multiple parts. It has both the system and the code, and we've talked about the fundamental idea of that is you don't understand the meaning unless you have both of those elements. The code system, the code in the code system is used to define the meaning, and you have to know what system it is and what the specific code value is to be able to actually to get that meaning. So we will leverage that in the searching, and we'll basically use the terminology to help us find instances of FHIR resources that utilize those codes. And so this one is about, we're going to be looking for conditions. We're going to be searching the condition resources for ones that have a SNOMED CT code for hypertensive disorder. And the URL you'll see here, well, there's a couple of things we'll mention about it before we click into it. I'm using my, the FHIR server that I've set up as an example, and it just so happens, it might be worth mentioning since we just had a question on it, that my server is based on the Happy FHIR server specification, and so I think Happy is a pretty good, solid foundation for a lot of things, and it has a fair bit of terminology capabilities, not as sophisticated as some others specialized terminology servers out there, but it's pretty good for a lot of the fundamentals. And so that's what my server is based on. And so we'll hit my server, the FHIR R4 endpoint, that we'll look at the condition resources that are on that server. And I've got quite a bit of synthetic data on there that we can draw from, so we can get results from that. And so we're looking at condition resource, and we're going to search on a code value with a particular, again, system and code. So we have the code system here, and you see the escaping, because not all servers require this. Some do, and some do to more or less extent, but the escaping is often the best practice in order to make sure there's no ambiguity about what's being sent in the query string. And so we have basically the system URL for SNOMED, which ends here. And then we have this red, escaped value, which is actually that vertical bar character that separates between the system and the code value. And so that's the red here, the %7C. And then the code, the SNOMED CT code value itself for hypertensive disorder is 38341003. So if I click on this link, we should see some results. We do. On my server, it looks like there are 214 condition resources that meet that criterion for having that code. And I'll, of course, won't look at all of them. I'll make it a little bigger because this will be pretty hard to see at that small size. But anyway, what we'll see here, you can see that we're basically returning a resource. In this case, this is one of the 214 condition resources. And if I scroll down through it just a little bit, we get to the code element, and you'll see we got the code element is a codable concept. Its name is code, and that can be a little confusing. It's not the code data type here. This is the element name in the condition resource, and it has a coding element inside it. It can, since it's a codable concept, it could have more. It could have more than one coding. In this case, it only has one, but that coding has a system of SNOMED CT. What you saw there, and it's got that code value that we set up, and then it also has a display string for hypertension. So anyway, and there's like 213 others of these, but they're all pretty much looking the same. So that's all we'll look at right now. But that's a simple search, but it can be fairly powerful to get. If you know exactly what you're looking for, that's how you can get it. There's also other kinds of things that we can do. You could, if you want, I don't necessarily recommend this so much, but you can basically only search on the code, and that will return, that would basically be saying, I want this, an observation, in this case, observation resource with this particular code 3141-9. And I'm not going to tell you what code system it is. And it happens to be the LOINC code for body weight measure, but I'm not specifying LOINC. If we do that, we'll still get results. I'll just show that. But there could be problems with this. If there was another code system that had the same value, then you might get something with an entirely different meaning return. So it's really not the best practice to not, you really should include the system like we did in the previous example. But this is just to show what can be done. All right, so that's the token search. It's pretty simple. And that's the first part of it anyway. I just forgot there's a second part of this. You can also do something that actually might be useful in some cases. You can actually search for a data that's coded in a particular code system, but not with any specific code. And to do that, you have to include the system value and the vertical bar. The vertical bar, again, is these last three characters here. Oops, let me do that. And but you can, so basically this will return allergy and tolerance resources that have any SNOMED CT code in the code element. So take a quick look at that. Again, we have to make these bigger. Okay, so let's look at a couple of them that we get here. We got an allergy and tolerance. We get down to the code element. We've got a latex allergy. So it's, again, we see SNOMED CT. It's got this particular code and display value. Let's see what the next one is as well. In this case, we've got an allergy to ibuprofen. So we got two completely different codes, but they're both SNOMED CT. So that's how that works. All right. And you could also search, basically for something where the system property did not even exist. Somebody defined a code, but they didn't give it a code system. That should be really rare, and I don't even know why people would want to do it, but the specification actually lets you do it. And I put in some example data just to show that would work. I defined a code allergy 4387, and I created an instance which basically does not specify any code system, and the server can find it. But again, wouldn't really recommend people do that very much. Probably never, but it is possible in FHIR to do it. All right, so now let's move on a bit, and we can start looking at modifiers. and these are particularly, there's multiple kinds of modifiers you can do, look at in your searching, but these are ones that are more dealing with terminology specifically. So again, we can use the text modifier. That's the simplest. We can basically just say, I want to find data with codes that have this string in them, angina, or a substring of that, ANGIN, and we can look for, in this case, condition resources that have those. So I'm going to click on this one, and we should see something with that. It's got to think a little harder, but it doesn't take too long. Okay, so we've got again, number of instances returned, and we got condition resources. And let's move on down to code element, and we sure do have a display string that says angina. We might also, I don't know, we could maybe find other codes that had something else. I don't remember if I have any. Probably they're all going to be the same. I'm not going to look through all of them, but we could also do a partial string search there, and we should see some results from that too. We don't have to give it the full term. And we ought to see, again, we've got the same ones that have code angina, so that works as well. And ibuprofen is similar. I'm not going to click on that one. It's not really any need to. You can also use, in addition to the text, there's a modifier for not, it's not that token. And so this one would be, that your severity is not a particular code. And so the code, this particular one, 255604, is for mild, and we want any resources that basically are not mild, that have a severity that's not mild. So if I click on that, let's see what we get. We'll get a few. Severity is what we're looking at now. Again, we have condition resources. Severity, in this case, we have mild to moderate. That's not the same as mild, so that's okay. What else do we have? We have moderate, that's not mild. We probably have, severe, so we have a variety, but one thing, if we look through here, we'll not find any that are actually mild because we excluded that. So we can do things like that. Okay. And now we're going to move up another step, basically, maybe to modifiers that are based on value sets. And in this case, what we're trying to say is I want to find, again, let's say condition resources, in this example, that have a code that's in a particular value set. So I want to look for things like, I want to look for conditions of upper respiratory infection. So if I have a value set that has the codes in it, defined it for upper respiratory infection, then I can use that in my searching. So let's first look at the value set so we know what it's doing. That's this. It's a fairly simple value set. Like you saw some of these things before in the first part. We've got the value set resource. We've got the compose element, which gives our definition. So we're going to include codes from SNOMED CT, and we're going to filter the SNOMED codes based on are they one of these, this 5415009. And I think I didn't put that on there, but we actually could go find what that code is just to show. Let's see, if I look up the SNOMED browser, I should have put this up here first, but it's not too hard to get to. I just do that, and we'll just quickly look at the international edition. Go here. Yeah, let's just take a look at what this is. So, oh, I copied the wrong thing there. So let me go back here and grab that. Not sure why that didn't copy, but it should have worked. Yeah. All right, so yeah, so just to prove that I was on the right track there, that's the SNOMED CT concept for upper respiratory infection. So that's, again, that's our value set. Now, again, it doesn't enumerate what codes are upper respiratory infection. It just leverages the power of SNOMED to do that. It says, I want any kind of upper respiratory infection that's defined in SNOMED CT. So with that, let's look at what that expands to. We can look at again, what set of codes is that actually in SNOMED. We'll get that using the expand operation here. So we got it there. We'll talk more about expand in a moment. But anyway, so we got an expansion. Then now it gives us a list of codes, 134 of them to be exact. That's the total. And there are various kinds of upper respiratory infection. You've got a bacterial, upper respiratory bacterial infection, fungal infection of upper respiratory tract, and so on, including the common cold. So that's, we're basically searching for any of those 134 concepts when we do this next query. And so I'll click into that. And that was actually pretty quick to be able to do that. That's good. And so now we should find what we should find, again, condition resources. And when we look at the codes, it should be some kind of an upper respiratory infection. So this one's acute viral pharyngitis. I don't know if we probably have a lot of those, I'm guessing. I think if I go just a little further, I'll find some that are something else, but take too much time on that. Yeah. Let's see. No, maybe not. I think maybe they're all the same, but that's just because of the characteristics of the data set I'm using. But anyway, so but anyway, you can leverage the power of terminology to find, find data. That's the basic idea here. So then we can move on one more step and look at subsumption-based modifiers. And this is something basically says, I want to, I haven't really defined a value set for this, but I know SNOMED can deal with this. And I just say, I want to find all of my conditions that are some type of diabetes mellitus. I don't have a value set that I'm going to specify. What I'm going to do is I'm going to say, I'm going to use the below modifier. I'm going to say, I'm looking for a condition with a code that is below this particular SNOMED CT code, which is, again, the 732111009. That's the code for diabetes mellitus in SNOMED. So I should be able to find all types of diabetes mellitus by doing this. And let's give that one a shot. I think this can be, it's pretty powerful, can be pretty useful. And might take just a little longer to return. Let's see how we're doing on time. We've got some time. So, okay, we got 58 examples of that came back. That's not bad. All right, so we have, okay, this is code 44054006, which has a string of diabetes. Let's go back. It's not the code that we put in. It's not the 732111009 code, which is diabetes mellitus. It's this code. And I'm going to do the same thing I did before and go look at it in SNOMED real quick, because I think that display string doesn't tell you the whole story on that one. It actually should be one of the, yeah, so the actual code there is for a type 2 diabetes mellitus. And I'll drill in. These are the actual SNOMED CT descriptions for that particular code. It could be any one of these. These S's are synonyms, and this is top one is the fully specified name, but it could be type 2 diabetes mellitus or diabetes mellitus type 2, or with the numeral 2 instead of the Roman, and all of that. Those are the actual strings that are in SNOMED. And so one reason I did that is I wanted to point out that the string here that you see for display, since it's part of the coding, the specification actually says that this string is supposed to be one of the strings that SNOMED CT actually defines for this concept. In this case, this violates that because diabetes is not one of those displays. So, you know, the server's not going to tell you that's an error, but if you you ran it through the validator, it should give you at least a warning message about that, and saying this is not a display string that I know about. So just be aware of that. But anyway, so you see that particular code coming back, and let's see if we should have some others. And let me try to think. Oh, I think we can find. Obviously, let's see what I can't remember what other ones are in here off the top of my head, but let's just take a second to kind of scroll down here and see if I find some other ones. And so far, I might be skipping over some, but anyway, you can do that at your leisure too. This data is out there on the server, and you're welcome to hit it any time. I can probably add more data to it eventually and have some other diagnoses, but any type of diabetes should be able to show up there. Again, we showed a bit of what those would be. So, you know, insulin treated, or, you know, remission with ulcer without complication. If you had any data coded in any of these, those should all show up. So that's how that works. All right. We also have a grayed out here because we're not going to do it, but there is, in addition to the below modifier, there's an above modifier, which would go and look at for any code that's higher in the hierarchy. So in the case of SNOMED, again, that would be something like, you know, we have the code for diabetes mellitus type, let's see. Yeah, for diabetes mellitus type 2, its parent code is diabetes mellitus. You can see that. Also, it could be disorder of glucose metabolism, or disorder of endocrine system, or something else, you know, carbohydrate metabolism. If you had data coded in those higher level concepts, that would bring that back, but it would be really unusual and rare to really need that in a search. So we're not going to go into that any further. All right, so now the last bit of this, I want to talk more detail about some of the terminology, service itself, and operations, and some things. So the rationale for terminology services is that there's a lot of complexity. You've seen a lot of this. We've kind of flew through the first part and shown some of the searching part and all that. Just things are, terminology can be quite complex with hierarchies like SNOMED has, and other things like that. You've got all these code systems, value sets, and bindings. But most applications, or at least many of them, are quite a bit simpler, and they just basically have lists of codes and displays and some kind of table or something. And so this kind of is a disconnect that's kind of a known problem. And so we try to use terminology services to help solve that problem. And delegates the complexity to the specialist software, and it can provide a set of services that do what applications need, and helps them to be able, application designers and developers to be able to do terminology well. Leave that special hard stuff to the guys who are really focused on that, and provide that as a service. Okay, so that's why we're doing it. And some of the things that we do with it, applications may need things like, may need a list of codes, maybe to populate a drop-down list for user selection. It might come from a value set, for example. Or I've got data, and I need to, somebody sent me maybe, and I need to find out, is it valid? Did they send me real good stuff or bad stuff? I need to know if this code is actually a valid SNOMED code or something like that. So, is it in the value set that it's supposed to be? And I can check that using the terminology services. Or I got to just have the code, and I need to figure out what to show to somebody, so I can go find the display string for that. It's a preferred, or maybe I got a string in one language and I need to display in a different language, and the code system actually might have that. So I could leverage that, and to know what I would display in my application. Okay, so those are some needs, and there's a couple more. I might want to translate this code. I have a diagnosis that was coded by a clinician in a clinical application in SNOMED CT, but now I need to submit a claim for the services, and I need to use ICD-10 for that. Well, maybe there's a mapping that would help get me from a SNOMED code to an ICD-10 code for this, so I could leverage that. Or I'm building an application and I need to, be searching, for things, using terminology, and I need to integrate that into my application. And maybe I want the user to be able to type some characters in and then find, likely concepts from the terminology. And so I can build a type ahead search, like for an allergy list or something like that. And I can use ValueSet expansion to give me the list of codes that, and I can vary it more. I type more characters and I get a narrower set. I can use some of the capabilities to do that sort of thing. So let's see. So the terminology service operations, these are, list of them. The ones that are bolded were the main ones we'll take a look at here. There's a few others that we won't have time to look at today, but the ValueSet expand and validate code. And we can also do the validate on codes. We didn't highlight that, we should have probably, but in CodeSystem, we can also look up things to get those details we were talking about, or to find out, how does this code relate to another one in the hierarchy with some subsumes, and then we can do the translation. All right, so take a look at expand. Basically, the idea of this is fairly straightforward. It takes that ValueSet reference or a resource and returns another ValueSet resource that contains that expansion code set. Again, these are the codes that are actually based on my ValueSet definition and the current state of the code system and the terminology that the terminology server knows about. What is the actual list of codes I should be working with? And that this expand operation is going to tell you that. It's by default, it's the current expansion as of right now. You can use the parameters to change that if you need to, and make some other modifications. But if you just do a straight one, you're getting it as of right now, according to what the terminology server itself knows. It's possible that a terminology server may not have the very latest version of a code system or whatever, and so it can only give you what it knows. So you have to be aware of those possibilities. All right, so this is looking at what we call an extensional ValueSet definition, which is basically an enumerated list of codes, and show how that works with an expand. So quickly drill into that. So again, we've got a ValueSet, and we're going to focus on the definition here. The composed element includes SNOMED CT codes, and this is a list of concepts. This is the extensional enumerated definition. I don't have displays here to show what these are, but you'll see them here in a second. So we've got 1, 2, 3, 4. We've got 7 concepts here in our definition. And when we do the expand operation, now the server will process that definition and it will return, it's actually giving us back the definition so we can compare them. Servers don't always do that. They don't necessarily have to do that, but they can. And this says, I'm returning you 7 codes based on that definition, and this is what they are. And I'm going to give you some detail about it too. I'll tell you, the display strings. So now I can see what they are. In this case, I'm getting back the exact same list that I put in, but it may not always be that way. If one of those codes in my definition, let's say, was inactive, then the default on expansion would be to not return inactive codes. So you might, if one of these was inactive and the others, and the other 6 were active, you'd get back only 6 codes in the result. But basically, it's mostly what goes in comes out in that way of defining. But so there's that, and now we can do the similar thing, but with the intentional. Again, this is intentional with an S, and it's ValueSet definition basically means it's defined based on some kind of query, and query of the code system define a set of codes based on the code system properties, filters, and all that. So we can do it real simple. We can just say, I want all codes in the code system. So in this case would be the observation category ValueSet we're going to look at. And this is HL7 ValueSet. And basically I'm just saying, I want, my value set definition is really simple. It just says I want to include this system, this is the, again, the HL7 code system for observation category. I'm going to include all codes in that code system. And when I do that, this is what I get back. I get a set of total 9 codes, and they are, the various types of observation category that have been defined in that value set. So again, expansion gives you back the set of actual codes as of right now that you're going to use. Now, you can also do this with a little more complicated definition using, using the terminology hierarchy, in this case with an is-a relationship. And I'm going to look at the route of administration, codes in SNOMED CT. So I'm going to define my value set. I'm going to call it the route codes value set, and I will define it like this. Let's see if that's big enough. Yeah. All right. So again, it's a pretty simple definition, but it's a little more than we had on the last one. We've got a single include element. Again, we got SNOMED CT codes we're looking at. In this case, we're using a filter, for concepts that have an is-a relationship to this particular one. I didn't give you which one that was, so we'll go look at it. Okay. Second here. Thought I copied that. Let's try again. Let's see how we're. Yeah, and that's a route of administration value in SNOMED CT. All right, just to show we're in the right place. Okay. Oh, I'm sorry, I did have it down there. I don't know what I was looking at, but anyway, the idea is though that's we're basically giving it that one concept, and it should has 52 children according to this, and we'll see what we get back. We're going to expand that and see what it gives us. And in this case, that was 52 direct children if you look at the browser, but we actually have 162 descendants in the current version of SNOMED. So these are routes of administration, like NI, interlesional, submucosal use, interstitial, topical, again, 162 of them. So that's how it expands based on that, that query-based value set definition. Let's see. So we've got a few more minutes to go through the rest of these. Validate code, basically, again, saying you can do it either on the value set or the code system now as of R4. You can also do it directly on code systems. And it's really, this tells you true or false. Is this a valid code? Either in the value set if you're doing it on the value set resource, or is it a valid code in the code system? And it's a primary, really the primary method for validating the coded data. And so the value set example is this one. We're going to look at, it's basically this problem list item. The code for that is that a valid code in the condition category value set. That's what this is doing. And in fact, it is. And it just returns true, basically, pretty simple. And also gives you, in this case, the display. Okay. And we can also do the same kind of thing with a code system. Not every server has implemented this yet, actually, but this is the, this would be the, again, a code, SNOMED code for pneumonia. And is it a valid SNOMED code is what we're asking here. We're hitting Peter Jordan's server in New Zealand for this. And again, it's true, and so it is a valid SNOMED CT code. All right. Lookup is something if you know the code and the system and the version, if you need to be specific about that, or even a coding itself, or you can pass that in as well, as rather than just a simple code. But it gives you additional details about it. So you could also use it if you want to determine if the code's in the code system. But if it isn't, instead of giving you a true or false, giving a false like the other the validate code would do, it will actually give you an operation outcome, an error message if the code doesn't exist. But you could end up doing the two things in one operation rather than two if you wanted to. So example, I've got 3 of them here because I wanted to show how different the results might be amongst different servers. I think this is pretty instructive. So this is the happy-based server that I have, and we're looking at, again, the details for the code for Snowmed code for pneumonia. And what happy returns is fairly straightforward and simple. It basically says that, it gives you a display string of the pneumonia disorder, and it says it's not an abstract code. And that's basically all it says, but it is valid, at least didn't give you an error. But if I look at the same thing, if I use the FHIR build server, the tx.phir.org, Graham Greaves server, for the same code, this is what I'm going to get. I get all of this detail. I get the display of pneumonia, I get other designations, the synonyms, the fully specified name, I get copyright information, I get that it's not inactive, I get the Snowmed module ID, the normal form, you can just see it keeps parents, children, I get an incredible amount of detail, again, so servers can decide whether they want to do all of this, like this server, or only what Happy's doing, and they're both valid, but they can be vastly different. And now I've got one more example just to show Peter Jordan's server in New Zealand, again, what it would do for the same code. It kind of strikes, I think, a happy medium maybe between those two. It gives a lot more detail than Happy does, but a lot less than what Graham's does. So anyway, that's useful to be aware of. All right, in our last bit, let's look at a few more things. Let's look at subsumes. And this is basically looking at that hierarchy. And again, it's related to code systems like Snowmed, which have a lot of relationships and hierarchy built into them. It can be used for simpler hierarchies too, but it's basically saying, if one of these codes is above the other in the hierarchy, again, when I'm talking that, I'm saying something like, and this is the route of administration we were looking at. Is route of administration, is it below qualifier value in the hierarchy? If it is, which it is in this case, which you can see, that basically means that qualifier value subsumes route of administration value, because when you say subsumes, it means it's at a higher level in the hierarchy and it includes everything that's underneath it. So qualifier value in this case would subsume route of administration and a lot of other ones. Route of administration, on the other hand, also subsumes these 52 concepts and their subtypes, those 163 or so that we saw in the ValueSet expansion. Those are all subsumed by route of administration value. So that's what that's talking about. And it can tell you whether, maybe the two codes are actually the same, basically the same, representing the same thing. And if so, they return that they're equivalent. Or if code A is at a higher level than code B, you'll return subsumes. And if code B is at a higher level than code A, it'll return subsumed by. I should say the other way. Code A is at a lower level than code B. It's code A is subsumed by code B. That's the way you need to read that. And then if they don't have any relationship between them, you can get a not subsumed return. Or if the server can't figure it out, it gives you an error message. Anyway, so with all of that, this is kind of a couple of examples. So we're looking at the two codes, Snowmed codes for viral hepatitis and disorder of liver. And we'll start with, we'll say what's the relationship of code A, viral hepatitis, to disorder of liver? Is it going to be subsumed or subsumed by or something else? Okay, so viral hepatitis is A, disorder of liver is B. And we basically find out that viral hepatitis A is subsumed by disorder of liver B. And that makes sense because viral hepatitis is more specific than disorder of liver. So that makes sense. If we reverse them, we basically do, we'll get, obviously, we'll get basically, if we say, what we're saying there is disorder of liver subsumes viral hepatitis. So that makes sense. And then let's look at two other codes. Let's look at malarial hepatitis and viral hepatitis and see what we get there. And we see that those two are not subsumed, okay? And we could prove why that is if we go through the hierarchy and all that, but maybe we won't do that right now. But that's how subsumes works. Translate is basically about, how do you translate this to another code system? And I think I'm going to have to, we're just about done with the time here, so we can go to questions, but I think we just have a couple more slides on this. So uses the concept map for translation or knowledge that the server has and all that. So I might leave that for an exercise for the reader. Actually, I think we can do that. I'll just hit the kind of the last bit of this, but just to see what the output looks like. You get a parameters back and you get whether their matches are found and the equivalents equal, and you basically you put in this case, I put in the code for contended, and I got back another translation code for happy. Now, I don't know exactly why those relate to each other, but that's what the example shows. And you can see that if you go through all the details of the concept map. All right, so this is a slide with a couple of useful ideas about search results can be paged, and that can help, in terms of performance and all of that. And you can also do the same thing by only requesting specific elements to return, particularly in a server that gives you this big list of things. Like Graham said, you might want to be more specific and parsimonious about what you return, and you can do that if you need to. So we are now at our question time, and I think we've got about, about 13 minutes or so at least for some questions on all this material, I think. Again, I think it's a pretty quick run through, but so we're happy to, if I missed some things, we can hopefully fill in some details here at this point.
Thank you, Rob.
Yeah.
Do we have any questions? So I see one more question from Alvin. If countries do not have license for SNOMED, what's the best code system that they can use? Do you have any ideas on that?
Well, that's very dependent on what specific domain you're working in. There's multiple answers to that question. One thing I would say, one thing to, at least to consider, is if SNOMED would have been your choice, if it was available to you, you may look at the SNOMED global patient set and see if it could meet your needs, either the way it is now or possibly if it's expanded in the future. SNOMED international folks have basically, particularly for uses like the International Patient Summary and other things, have basically indicated their willingness to look at needs that are out there and maybe include additional content if that's presented to them. And so that's something that can be considered. But you may, in some domains, you may decide a different terminology is better for you. So if you're looking at diagnoses or whatever, you might decide that, ICD in either the WHO version or one of the, national varieties of it, depending on what country you're in, might meet your needs for that. It's not generally considered as good from a clinical perspective. It's more of a classification, but it may work, and it is often in wide use, and so that might be something to consider. Medications, for example, you might look at ATC, you might look at IDMP, which is a little more from the regulatory space, and it's really kind of up and coming. It's not, it's not quite there yet, really, but it's coming along. And there's multiple choices in most domains, but it's very domain specific.
Indeed. So so jumping into that, so indeed there will be lots of purposes for which you want to use value sets or code systems. SNOMED being such a comprehensive code system, it's hard to say what replaces it, because in some parts one might be the other, might be the replacement. In the other part, you might need to create something else or something on your own, as little as possible, of course. But yeah, SNOMED is a hard one to say there's a replacement for this.
Yeah, there's not definitely not a single replacement for all of it, but
definitely.
Yeah.
Any other questions that we should discuss today? Okay, then maybe we can just advance. So just start wrapping up. So still feel free to post questions on the chat and to bring them up in audio if you want. But as a final recommendation, as usual, get in touch, be active in the community. So both Rob and myself and others, we are very engaged with the FHIR standards, and we really welcome people to come with questions. More advanced questions on a specific topic, or very newbie questions. Sometimes I have newbie questions on many things. Rob has sometimes as well, not newbie questions, but some questions that the community has to answer. So it's a really great open sphere or open community that we have in FHIR. So check with the others. Look at chat.phir.org for a live interaction, community.phir.org for like posting your questions, and the next day see what's happening. If you want, also if you have some needs, as Rob said, if you feel that something is wrong or something should be improved or something is not clear enough for you as an implementer, feel free to create or ask someone to create a change request to the FHIR specification itself, or to add to any of the implementation guides that are being produced by HL7 and by other institutions. Depending on your preference, but consider joining a FHIR event like Dev Days, other meetups. There's lots of things happening around FHIR, and it's always good to join those discussions, especially now that something or many things are still remote. You can join the working groups in another country just to see how they are working. You can join some discussions if they let you, of course. But there's lots of things happening that might be interesting to join, and FHIR Connectathon. So if you have systems to test, definitely join a Connectathon. If you don't have systems to test, but you want to see how would I address this kind of problem, how would I work with this kind of thing. So some of these discussions that we had today, they would even be good discussion topics for Connectathons. So go in to test, not only to test, but to provide some feedback on the specification as it is in FHIR or a specific implementation guide. But the main thing, get going. So that's the purpose of our sessions. Get going and start to have the feeling of how things work technically. So if you want to roll out a server, ask around. In a few minutes you'll have an answer, like you can start here or there. If you want to roll out your own terminology capabilities, that should also be something that's easy to help you get started. Ask around and get people to help you get things in practice. As an agenda conclusion, let's say for today, just a reminder that this was the third session on FHIR enabling sessions. We have one next month on FHIR implementation guides and advanced usages. So where we take the outcome of these three sessions. So we take the basics of FHIR, we do a bit of profiling and how to do documentation and the terminology, of course. And the idea is that on the 28th of July, we will be seeing a bit of how and when to make an implementation guide of your own versus when seeking out some implementation guides that exist. So how to look for them, how to select something, or how to make your own implementation guides if you want to, if you want and if you need to. So that's our next session that we'll have. Please join. And Rhonda, I don't know if you want to wrap up.
Yeah, just quick thank you to everyone for joining. We do have a fireside chat coming up on July 16th. These are informal sessions where Jose will answer questions. So if you have a question that you'd like some help on, please do join us for that. The Google Doc has all of the registration links for the chats as well as the upcoming sessions. And we will share this recording in the next few days. So thank you so much for coming. And thank you to Rob for hosting or for walking us through all of that. And Jose.
Thank you very much. Bye-bye.
Yes, thanks. Thanks very much. Really